the following exercises, solve the equations over the complex numbers. Okay, so we've done tons of problems with complex numbers. If you want to check the playlist out, the link is in the description. It's called Complex Numbers. That is where we've done tons of problems dealing with complex numbers. And just remember that complex numbers are non-real, right? They are not real values. They are imaginary. So we are constantly going to be dealing with the letter I, right? And I'll put it over here. I is just the square root of -1. It deals with this non-real possibility of having negative values in the square root. Since we're dealing with complex numbers, we're probably going to see this at some point. But for now, let's just go right ahead. Now here we need to solve the equations, right? And you notice that this quadratic equation is equal to 0. Whenever your quadratic equation is equal to 0, just as like a little back story here, what you're doing is you're finding out, let's just pretend that this is the graph, right? And I know that it's a smiley graph because my a value is a positive value. It's a 1. We've done tons of problems like that explaining that concept. You're basically solving for your x values in which your y equals 0. Those are called your roots. And quadratic equations will have 2 roots. So in this instance, there will be 2 answers. One will deal with the positive end, and the other one will deal with the negative end, right? So you'll have 2 answers. One is equal to a positive value, and the other one is equal to a negative value. But that's essentially what we're doing here. When you always have a quadratic and it equals 0, you are solving where on the graph does your quadratic intersect with the x-axis. So that's what we're dealing with in a nutshell. Now, can we actually do algebra, straight up with an x squared value and an x value? No, we cannot. We need to do different types of things, but there's a handy dandy formula that we have to memorize depending on what your teacher or professor says, which is the quadratic function. You will use the quadratic functions to solve for your x values when you want to find out those roots, okay? This equation is only used for quadratics. It's only used for equations that look like this, where you have an x squared and an x. So the first thing is, when we're dealing with the quadratic, is we need to find out our a, b, and c values. So I'm going to list up top here, what is my a, b, and c values for this equation? Well, remember, the a is always the number in the front. The b is always the number, I don't want to say the number in the front. The a is the number that is always with the x squared. The b is the number that always is with just the x. And the c value is always the one that's by itself. So, if we go by that, my a value would be 1, my b value is a positive 2, and my c is a positive 5. I'm going to use this information and just plug it into our quadratic equation. There's a song for this. I'm sure if you Google, quadratic equation song, quadratic function song, you'll find something, okay? So what I'm going to do is the quadratic function gives a function in terms of b's, a's, and c's, a, b's, and c's. You just have to plug in your a, b, and c values into this equation. So what I'm going to do, because there's pretty limited space, I'm going to write out the quadratic equation a little bit big, and I'm going to, you'll see, I'm going to erase as I go along. I think that's a good idea. So let's see. So x equals negative b was a 2, so negative 2, and I'll just try to color code this, plus or minus the square root of b squared, b was 2 again, so that's 2 squared, minus 4 times a, which was 1, times c, which is 5, and that's all over 2 times a, so 2 times 1. Okay, so the rule of thumb is that you always work inside the square root first. Okay, so this is the first step. So what we're going to do is we're going to simplify inside this radical. So 2 times 2, not 2 times 2, but 2 squared is a 4 minus, okay, 4 times 1 times 5. 4 times 1 is 4. 4 times 5 is 20. So this would be a minus 20. You see how easy this is if you just do it in parts? Now you can clean this up at the bottom. 2 times 1 is the same thing as a 2. So this would be all divided by 2. And now 4 minus 20 looks like that's a negative 16. Okay, so now where do we go from here? Once you simplify everything and you only have one number under the radical, this is simplified and this you can't really do much with it. You work with the radical. So now you're going to be doing the square root of negative 16. But what is the square root of negative 16? Well, if I type this into the calculator, you're going to get an answer that says, either A, your calculator is going to explode. It's not going to. Or it's just going to say no real values, right? Error. Because the calculator doesn't understand imaginary numbers. The calculator doesn't understand the negative in the square root. That's where we have to include our I value. And I just realized that I didn't put a number here, or maybe I accidentally got rid of it. But this is always the square root of negative 1. So what we're going to do is we're going to separate the square root into negative and positive components. Remember, this is just the same as saying the square root of negative 1 times the square root of 16, right? Negative 1 times 16 is negative 16. And now you have two independent radicals that you can solve. We know that the square root of negative 1 is I, and we know that the square root of 16 is 4. So this would be the same thing as I to the 4th. So the square root of negative 16 is just the same thing as saying 4i. So now I can kind of I could kind of move this over here. I got way more room here. So we have 4i. Get rid of this. Actually, yeah, that's much better. And maybe I'll just bring this over here because we need more room for the other one. So this was the square root of negative 16. This breaks down into this and this. Okay. So now where do we go from here? You tell me. What? I can't hear you. So when we're at this stage of the game, you will break it down into its two components. You will break it down into its plus and minus different values. So what that means is, if I just pull this up here, you can say that x was equal to negative 2 plus 4i all over 2. Or you can say x was equal to negative 2 minus 4i all over 2. And now we go back to simplifying, right? So you might be able to leave it like this. It doesn't matter to me, but just know that if you have the same number in the denominator, you can split them up, right? So I can say that this was negative 2 over 2 plus 4i over 2. And then the same idea over here. This could be negative 2 over 2 minus 4i over 2, and it kind of makes things a little bit simpler. Negative 2 divided by 2 is 1, right? And then 4 and 2, you just have a 2 over here. So I have an x equals negative 1, negative 1 plus 2i. And then the same thing, right? You have a negative 1 minus 2i. And there are your two answers. Okay. That's it. So these are your roots. Let's go to the next one. We have x squared minus 4x plus 5. We need to solve using the quadratic function. So x equals this negative b. So actually, before we do that, let's just list out our a, b, and c value, right? A is in front of the x squared, the b value is in front of the x, and the c value is all the way at the end, right? So a, b, and c. My a value is a 1, my b is a negative 4, and my c is a 5. Now let's plug that into the quadratic. So x equals negative b, which was a negative 4, plus or minus the square root of b squared, so that's a negative 4 squared, minus 4 times your a value, so times 1, and then times your c value, and that's all over 2 times a, which is a 1. Okay, we always clean up under the radical first. Negative 4 times negative 4 squared, is 16. So I have that going for me. Minus 4 times 1 times 5. 4 times 1 times 5 is 20. So I have a minus 20. Clean this up. 16 minus 20 is a negative 4. I can clean the bottom up. 2 times 1 is just a 2. And now I have everything nice. Now a negative times a negative is a positive. So this would just be 4. So sometimes you can clean stuff up, as you go. So now we're at x equals 4 plus or minus the square root of negative 4 all over 2. Let's now do what the square root of negative 4 is. Well, the square root of negative 4 can be broken down into the square root of negative 1 times the square root of 4. You have to break off that negative 1 to get your imaginary numbers. I know that the square root of negative 1 is an I, and I know that the square root of negative 4 is 2. So this would just be 2 times I. This would be the I component, and this is the 2. 2 times I is 2i. So I can just erase that, right? 2i. Now, what you also can do is, if you want to just break off the denominator now, you can. So maybe we'll try that. So instead of saying it's all over 2, this would be 4 divided by 2 plus or minus 2i divided by 2. I think that makes it easier because then you only have to do the division once. So 4 divided by 2 is 2. So I have x equals 2 plus or minus 2i divided by 2. 2 divided by 2 is 1, right? So this would just be I. So now here are your two answers. X would equal 2 plus I, and then x would equal 2 minus I. And those are your two answers. And there you go. So guys, what do you think? Let me know in the comments if this helped. Give it a thumbs up and subscribe to the channel if you'd like. And I look forward to helping you with additional problems. And I'll see you guys all in the next lesson. You guys have been great. Have an awesome day. Bye-bye.